Hi everyone, this lesson is going to cover speed and velocity, and as always we'll start with the narrative. The motion of any object can be described in terms of displacement, velocity, and acceleration. I feel like we've said that so many times, but we're going to cover the first two, displacement and velocity. And the bullet point that this lesson is relevant for says speed and velocity, average and instantaneous. So we'll make sure that we cover all four of those topics. And we should always be asking ourselves, how is this bullet point relevant to living systems? 4A is all about living systems. So let's take a few examples. You can talk about the growth. That's a certain type of speed and velocity. You can talk about nutritional transport. Very relevant to living systems. Neural impulses. How we sense things and interact with our environment. Talk about animal migration habits. And then kind of a less literal, you can talk about the transmission of disease as kind of analogous to speed and velocity. This is not an exhaustive list, but just a start. So let's start with speed. And speed is a scalar quantity. It means it only has a magnitude, it doesn't have a direction. So the direction kind of doesn't matter inside the physics. And we'll just give a quick formula. So speed is distance over time. So kind of the distance you travel and the amount of time it takes you to get there. And it could be in circles. It doesn't matter. Just kind of the pedometer distance that you have to travel. And let's compare that to velocity. Now velocity, on the other hand, we mentioned before, is a vector quantity. It has a magnitude and a direction. And our velocity, and I'll put a little arrow to show it's a vector, is displacement over time. So you can kind of see we need to kind of get into a discussion on what is the difference between distance and displacement. And that's simple enough. It's in the narrative, so it's really important to know kind of for the exam. So if this is kind of my red path, my displacement is kind of the straight line distance from start to finish. And it's a vector. Displacement is a vector, which is why I get a vector quantity when I divide it by time. Now on the other hand, distance is kind of everything on this path. You would kind of outline this path with a string and you would walk this path and you would eventually get kind of your total distance. You can think of it as what your pedometer would read if you walked this blue path. Let's take a little look at direction, and we mentioned that kind of speed is a scalar quantity, so it's kind of what we really care about is the magnitude, and for velocity it's a vector quantity. So let's take a quick look. And you can see that speed can have many directions. On one kind of route, you can go many different directions. Let's give a quick example of that. So kind of, I walk this kind of light blue path, and there'll be certain moments in my trip that I'm walking kind of northeast. Here I'm walking kind of east. And there's times I'm walking back north. So you can see I went many different directions on this one path. Now for velocity, even though I walked many kind of directions, while I was walking, all you really care about is the displacement, which is the straight line distance from start to end. So my velocity would just be kind of a straight line. It has to have one direction, and it's the direction between my start and my finish. So maybe you'll ask, when is speed and velocity the same? And they'll be the same in kind of magnitude and the same in direction. And that would be whenever you're kind of traveling in a straight line. If you already are traveling in a straight line, then speed only has kind of one direction, and so does your velocity. So this would be kind of the only instance where they're the same. When you have many complex motions in a single trip, it's sometimes valuable to look at the average speed or velocity. To do this, you need to define the beginning and the end of the trip. You need to find either the distance or the displacement for the whole trip. If it's distance, you kind of trace the trip. If it's displacement, it's the straight line distance from start to end. We talked about that a few minutes ago. Simple enough. Next, you need to define how much time it took to travel the trip. So kind of just end time minus start time. And lastly, you're going to use the formula. So if it's speed, just distance over time, and velocity will be displacement over time. So we use this anytime you need to summarize a trip to a single velocity or a single speed. So the next topic is instantaneous speed or velocity, which is kind of the opposite of the average. And it's the single speed or velocity that describes kind of a single moment of time, like a freeze frame or a snapshot. So let's take a look. If you're looking for velocity, you might kind of ask, what is the velocity at exactly time equals 5? And the velocity at time equals 5 will be the same as the speed as time equals 5. It's just the velocity will have a direction and the speed won't. So the velocity at time equals 5. And if you want to zone in on time equals 5, you need to take the limit as delta t goes to 0. And you're kind of zoning in on time equals 5. So you're going to look at from 4.99 to 5.001, and then from 4.999 to 5.001. And then eventually, you get the slope of the d versus t graph at time equals 5. So this is just the derivative from calculus 1. So we can go ahead and draw a d versus t and see how this derivative plays out. It's simple enough. So I'm going to go ahead and start with this positive slope, and then a point where kind of the slope is 0. And then let me do a negative slope, and then how about we come back up positive. So you need to remember the formula for the slope, which is just kind of rise over run. So this first piece has kind of a positive slope, and then the slope is 0. We have a negative slope, and then we kind of have a steep positive slope, so we kind of have a steep kind of high velocity at the end. And the speed would just be the same thing. Instead of, you wouldn't really worry about positives and negatives, you just worry about the magnitude of the slope. And at these kind of changes of directions, you have no direction or no kind of velocity. At these singular changes of direction, you're kind of turning around. And this is just our d versus t graph. You don't need to know this for the MCAT, but you should kind of be semi-familiar with with the fact that the velocity is the derivative of the distance. So I say distance is 5x squared plus 3x plus 2. My derivative is 10x plus 3. And that would be kind of the formula for my velocity for any time x. So we've talked about the instantaneous speed, which is at a single moment in time, and the average, which summarizes a trip. So let's take a look at when you would use each one of these. So let's write down a few quick examples. We'll start with the speed of a neural impulse. And that's kind of how we sense things. We'll talk about the speed kind of at a certain blockage within an artery or a vein. The speed at launch could be a syringe or any kind of quick motion. We can talk about the speed of migration of some sort of animal. And last, we can talk about the speed of prey. And let's kind of ask ourselves, which one of these would we want to use kind of average speed or velocity, and which one does instantaneous better suit us? For the speed of a neural impulse, we'd be dealing with the average speed, and it's from the stimulus until the reaction. The speed of the blockage, it turns out that the instantaneous speed is more relevant. The higher the instantaneous speed, the more blockage. The speed at launch, and we said to kind of take the example of a syringe, is also instantaneous. Launch is usually kind of defined to be a single moment. For the speed of migration, we'll be dealing with an average speed or velocity, and we kind of define the trip to be the beginning of the migration until its end. And for the last one, speed of prey, I guess we could be dealing with instantaneous if you wanted to know which animal had the highest top speed for kind of a very short chase. But you could also be dealing with the highest average for longer chases, seeing which animal can kind of keep up a certain speed for the longest period of time, and you define the beginning and the end of the chase to be the beginning and the end of your trip. Thanks for watching. Please like and subscribe for more lessons.